Howdy folks, today we are going to be looking at Advent of Code 2024, Day 8. Let's take a look. Resonant collinarity. Okay. We find ourselves in Easter Bunny installation. That's exciting. Okay, there's an antenna. It does some signals. And it's been reconfigured to emit people wanting to buy Easter brand imitation mediocre chocolate. Well, that's not good. We can't have that. Each antenna to a new frequency and a single lowercase letter. You create a map of these antennas. Okay. So we've got another map. So we kind of can guess some of the code for that. A signal only applies its nefarious effect at specific antinodes based on the resonance. Okay. Perfectly in line with two antennas of the same frequency. Only one antenna is twice as far. Wow, I don't understand what that means at all. These two antennas frequency, they create the two antennas. Okay. So then, which of these is the antenna? I'm guessing it's A, but then what is the 0 here? Oh, tune the frequency indicated lowercase letter. Okay. So, or digit. So these are all frequencies. Okay. They create two nodes. A point perfectly in line with two antennas of the same frequency, twice as far away from the other. For any pair of frequencies, there are two antinodes. Okay. So we have, so this is the antinode and this is the antinode. Okay, so basically you draw a line between the two, double the distance, and continue along it. And the third antinode, same frequency, creates several more antinodes. Would ideally add 4 antinodes, or 2 are off to the right, since the only node's 2. Okay, right, because that basically you're drawing those lines. Antinodes deeper to different frequencies don't create antinodes. Okay, antinodes can occur at locations that contain antennas. So in this case, there is actually an antinode here, but it doesn't create any. First example is antinodes. Okay, so there's all the antinodes. Okay, so we're basically just looking for where the antinodes exist. Where did this one come from? These two come from here. Oh, because of this one and probably that A. Because there's a line in between. And I bet these two, it's the same line. Okay, so this is actually a little bit of a geometry problem. You have your map, and you basically want to find for every 2 pairs of these things, you draw a line between them and figure out where that line. Where's the original map that they gave us? There we go. Where that line kind of continues, really. So you're given a line segment, you need to extend the line. So let's start off with this. Okay, so we've got our map. Oops, let's pull in this. File equals path dot, yep, and sample one dot map. Okay. Contents. Read file. We gotta actually read file sync. Okay, so let's see. We're basically gonna pull in the map the same way that we did. Well, here's the thing. Actually, in this particular case, we don't care about the empty contents of the map. We care about the positions of all the antennas. So what I want to do is I need the width and height of the map. But that's easy to get. We really actually need a list of all positions based on their type, because antennas can't react with each other. So, and then we need an actual map of the antinodes. Kind of. But then in that case, we don't even care if that's a map at all. Basically, the idea here was we're moving from a space of this map here to an actual virtual space, and we'll just kind of be virtualizing the coordinates, so we don't really need to care about it. So let's do this then. Let's call this antenna list, and we're gonna loop. Oh, we need the lines. Okay, y equals, oops. let's just do a for each on this time. And then line dot split dot for each item. You know what? I do actually want the index on this, so let's call this is going to be the y, and this is going to be the x, which you absolutely can do in a for each. I don't normally use this format. Normally I'm using the for loop with an index just because I like that a little better, but this should be fine. If item does not equal to a dot, then we know it is an antenna. And this actually, I want to make that an object. If not antenna list, and this should actually be a map then. Antenna map of item, and we create it as an empty array, and then we're going to push xy. Perfect. So what that's going to do is that's going to give us an object that contains keys being the antenna, values being arrays of objects that contain the xy coordinate pairs. Let's take a look at what that does when we run it. Okay, so we have 0 and we have a, which makes perfect sense. So we have these coordinates, this coordinate, this coordinate. Cool. So then what we're going to do is we're going to do an O of n squared loop over antenna map. And pretty much go from every single item to every single other item. Let's see. I equals, that's exactly what I want though. But I want this to actually be, let's do this, for const antenna of first, and this actually needs to be in because it is an object. Now we can actually loop. Antenna map, antenna. It's a hard word to spell. I don't know if I'm actually spelling it correctly. I don't think I am. That should be an A. Unless maybe if you're British, maybe they spell it with an E, I don't know. Now we're going to loop over our coordinates. Oops. There we go. And our inner loop, we're going to use a let j equals I plus 1. Similar to before, because we don't want to have the same coordinate loop with each other, because if all you have is a point, you can't actually extend a line segment from that point or extrapolate where that line is, which means we can't get any useful information on it. So we now have 2 points. Point 1, chords of I, and this is coordinates of j. So if we want to find, we basically want to fill out the formula y equals mx plus b. And if we can fill out that formula, then we actually have the formula for this line. Because a line between 2 points that isn't weird or anything, we can always continue it along the line segment with this formula. We know y and we know x, and we're trying to solve for both of these. Well, b is the offset and m is the slope. Now, if we want to find the slope is going to be, we can actually triangulate that with the coordinates that we have. So we have 2 points, and the slope is going to be rise over run. So we have our rise, which is going to be the difference in our y coordinates over the difference in our x coordinates. And normally, if you're writing this down, you write it as a fraction, but we'll just do it as a decimal because we are actually computing these values directly. So let's see, we want the difference in, we want 0.1.y, 0.2.y. And I don't believe it actually matters which point is in what direction, because as long as you are consistent with which one is going first, I think. I guess we'll find out. And I might need to graph this to just verify we're doing the right thing. But then that means we have our slope times x plus b. And that means we can actually solve for b. Then at that point, b equals y minus slope times x. So we just need that for one of our points. 0.1.y, and then we get 0.1.x. Okay. Now we have the formula for the line, which means that if we have our slope and we have our, this is actually intercept being the point at which it intercepts with the 0. I think it's a 0y. It's like the x. It's either the x coordinate at which it intercepts with the y line or the y coordinate at which it intercepts with the x line. I'm not completely sure, but it's one of those two. Either way, now that we have that line, we can actually, we have our x, right? And so we can figure out our x coordinate of our two antinodes and feed that into this formula to get the y, because remember, we have y equals slope times x plus intercept. So if we know our x coordinate that we want, we can get the y for that specific point. Where is that? Let's say we have our 2 points here. Our anti-antenna, whatever they call them, are going to be the same x distance away on both sides. And you could say that, oh well, actually, there's two things we might need to consider here. Or one thing we need to consider is if the line is straight up and down. If the line is straight up and down, there is not actually an x position to deal with. Like, there's no difference in the x, so we can't actually use that. So we'd have to use a y in that case. So what we can do is we can actually determine. And the thing is, when you're dealing with little grids like this, it's also good if you're using the larger difference coordinate. So if the difference in x is bigger than the difference in y, it's better to calculate on the x, because then you get those minute changes better. Otherwise, if you're calculating on the smaller end, the math doesn't always end up very nice, and sometimes you get things that are offset one position from where they should be. So what we can do, let's get our distance in x, which actually is just the absolute value of this, I'm realizing. And then, and I could have also used that. I could have also used that in here, and that would have should have given me a correct slope. Well, actually, no, maybe it wouldn't. It wouldn't have given the correct slope, because sometimes the line goes this way, sometimes it goes this way. Yeah. Anyway, so we've got our distance. Let's see, if dist x is greater than dist y, if it's equal, then it doesn't really matter. And also, this is the easier formula to run. So if the distance x is greater, then we're going to use this formula. So we want 2 points on either side of the x, and what that means is that x anti-x1 equals, it's going to be point. We want to go off of, basically we want to go off of the smaller of the 2 points. So we should actually calculate small x. You know, let's do that inside here. Small x equals math.min point 2.x. Okay, and then we want small x minus dist x. Okay, and so then our anti-y1 is going to be equal to slope times anti-x1 plus intercept. Okay, so now we have our two pairs. And let's pop those in here. Pairs. And we're going to go put that in there. Anti-pairs.push. X is going to be anti-x. Oops. And y is going to be anti-y1. Okay, so then I actually want to just break at that point, because I want to see what we've actually done here. I only want to run over one of these, and let's just see. Okay. So our antipairs, we get 3. I have no idea if these make any sense at all. Let's see. So what we're doing is we're doing the first 2 sets here, the coordinates. Oh, you know what? Let's also break on this. I forgot we had that loop. So this is just going to be the first antipair of our first 2 coordinates. So our first 2 coordinates, I should probably console log those. Okay, we have 8, 1, and 5, 2. All right. And with 8, 1, and 5, 2, we get 2, 3. That kind of makes sense. Actually, what I'm realizing, it probably makes the most sense to just give ourselves something that draws our map. So let's figure out what is our width and height. So this is going to be width equals line dot split dot length. It's not the most clean way of handling that, but that's okay. Height equals lines dot length. Okay, so there's our width and height. And so what I want to do then is let's actually just loop over that. Equals 0, y plus plus, let x equals 0, x with x plus plus. And then, let's see. Antenna equals, that's actually going to be a little hard with these because this antenna map is actually set up in the wrong way. So what I want to do is I'm actually going to invert that. Inverted map. So instead of having this map by the item, I'm going to actually have it by the coordinate pair. Let's see. There we go. Does this work? No, that's okay. Dot map. Yeah, that's not right at all. We do want to actually loop over that, the coordinates. And what we're going to do inside there, though, is we're going to set a key. And we're going to grab our key. And we're going to set that. And inverted map key is going to be antenna. There we go. What did I miss here? There. So now we'll set up a key here as well. If inverted map. Inverted map's not the greatest name for this. A better name would be like antennas by coordinate or something. And that is definitely not what I want to do. Or maybe it is what I want to do actually, because I don't want to do a console log. Well, I can do a console log. Normally console log will actually put a new line, but you actually can fix that with I believe it's end. Oh no, maybe that's Python actually. Okay, never mind. It looks like it is just process. That's standard out that right, which is interesting. I've not used this before. Okay, else I'm just gonna write a dot. And then at the end of this line, then we will console log. And that's just going to give us a new line. So let's see. Okay, cool. So that should give us, that gives us our map. Perfect. Now, what I want to do is anti-pairs. So I need to invert the anti-pair map as well. Which is going to be a little bit easier because it's a little less complicated. Inverted pairs. Pair in anti-pairs. That's not right. Oh, I did call it anti-pairs. Okay. Inverted anti-pairs, and we're going to set this. We're going to get a key on here again. Pair.x, pair.y. To be honest, it might be more helpful if we're just using that key right off the bat, because we are going to need to, we don't want to push if we've already put one in there. Anti-x1, y1, and then we'll just, we'll set that key to be true. And that means this needs to be that. Very cool. So now we don't need the key. We can actually just, we can get the key just like that, I think, actually. Or no, we don't even need to invert it. Else if, we can just use it here. And then process dot stand out. I think they were using a hash. Okay. Okay, so there's our first one. That actually looks like that's correct. So let's double check that against here. Okay, that's 4 down and 3 over. 4 down, 3. Okay, cool. So I think that actually looks like that might work. Now, let's do the next one. Okay. And we actually need to check that key. If anti-x1 is greater than 0 and anti-x1 is less than width anti-y1. Okay, yeah, it's less than height. All right, we gotta, yeah. We only want to add it if it fits on the map. Okay, cool. Pop that in there. There's, you know, this actually needs to be greater x for the max because we're going to go the other direction. And this is actually going to be the great x plus dist and anti-x2. And then this just becomes a bunch of 2's. I'm getting nervous about this code because I feel like this is not lend itself very nicely to being refactored. And that actually should be off the map, I think. Oh no, it's right there in the corner. Okay. And there it is in the corner. All right, so let's unbreak this. We've got one down there, which is probably these two, I'm guessing. Okay, cool. And now we need to figure out the other case, this case. So if the y is smaller than, or the x is smaller than the y, the distance between them, we actually need to use another formula. So we have this formula, but if we start off with the y, then that needs to become y minus b equals mx, and then x equals y minus b over m. So that's how we solve for the x given we know the y. So let's just reverse this. We're working off the y now. Okay, anti-y. And we look at the small y minus the distance y. And this is going to be the x. So this is actually going to be, okay, the anti-y1, I can't spell, minus our intercept divided by our slope. Okay, and then this actually doesn't change. Let's see what we get for that. Actually, don't really get anything, do we? Huh. Huh. Okay. Maybe because, okay, so the only two that would have, this one would have that, so we should have gotten one down here, which I think is this one. Let's, x. Let's look at that right there. Okay, oh, negative, because it went off. Oh, because it's a small one, so it's going up. That's why. All right, let's do the large one then. And this is going to be the great y. I could do large, I suppose, but great just sounds better. This is 2, 2. And it's the same idea there, just a bunch of 2's. Oh, did I change that? There, yes, it did. Okay. And and we'll pop that in there and there. And let's see what we get. Okay, we're still not getting that one. Let's y2. Okay, so that's 8, 1. That should definitely be on here. It's actually kind of interesting though, because the point, that's actually 8, 1 and what? So somehow I got the same exact coordinate as our first one, which doesn't seem right at all. Okay, so that's a great one. Oh, it needs to be plus. That's why. Right, because if you, that makes perfect sense. Okay, we're still not getting that because, so that's 6, 5. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5. So it should be like right here. And that would be very reasonable for it to be there. Width and height to height. Okay. Let's just pop that in here and let's see. Okay, so it is definitely getting it. It is setting it on our anti-pairs. Oh, you know what? I wonder if there's actually a thing there. That might be this one, actually. So what about the other one? We should have some other ones in there. So we should have this one. Oh, because I'm breaking. That's why. Let's not break on that then. Let's do all of them. Okay, that actually looks better. That looks pretty good. So let's do all of these entirely. Where am I console logging? Let's stop console logging that. Okay, there's that. That actually looks pretty good. But let's pop it up here. Let's get ourselves a new, let's just double check. Okay, here's our output. And then we'll put this one next to it. That's not what I want. I want this. There we go. And we'll grab their output here. Oh, see, that's slightly off. One of those is just, maybe it's not actually. That looks very similar. Okay, I think that might be it. So then in that case, what we want to do is we actually don't care so much about this. We actually want to log the count of anti-pairs. Anti-pairs. And we can do that with object.keys.length. No, I don't want to save this actually. I don't want to save that either. And let's see. Okay, 14. And 14. Very good. Let's try it against our full input. There's a lot of ones in here. Cool. We'll go here, input 1. Might take a little longer. Okay, 330. That didn't take that long at all. I guess it's kind of a small map. And also, because we're not iterating over the entire map, really, we're just iterating over the pairs. Let's see. Oh, our answer is too high. Okay. Make sure you're using the full input data. Okay, well then maybe the answer is too high. Oh, you know why? Because, no, because we're pushing it in there. All right, well, let's console log that output then. Okay. So let's see here. This is probably going to be completely unhelpful, honestly. Well, at least we have an upper bound on it, though. Okay, so this is too high. So they're saying, hey, there's too many, you've got too many pairs going on here. I wonder why. Because we definitely got the correct output for the sample. We got 14 there. Somehow we're creating more for this input than we should be. Okay, so there's that. There's that. What I really need here is I really need a way to just debug through this whole thing, looking at just the individual types of characters, because I bet then we could find something interesting. So let's do this. Let's actually equals, we have our antenna map. So antenna types equals object.keys. So let's just get a list of all our antennas, and then we'll get the first one as our one to check for. And key, oops. Let's see, and then we'll actually go and check this. Oops. antenna. Oh my god, that's not what I want at all. That's way too big. So then we'll change this to if found antenna and found antenna is not equal to or equals our check key. And then we will print that out. So let's look at this. Okay, so that's just doing that, and that's perfect. So now let's look at our input. Okay, so this, oh, you know what? That's actually a bit of a problem too, because we're printing out all of these damn things. You know what? We're going to actually just set this equal to our antenna then. It doesn't actually matter what it's set equal to, so we can totally use that as a value. And if we do that, then we could say, okay, if anti-pairs.key does not equal to check key, or it does equal to check key, because we only want the ones for that. Okay, and then we get, okay, cool. So we get a couple. I'm going to debug through this a little bit and see if I can figure out what the issue is. Okay, so I have found a bug. You see here, we've got these two. These two produce that one. These two presumably produce something down here, right? This is produced by those two. These two here should produce one that's here, but they are not. So that's actually kind of interesting because what they told us is our answer was too large. But this shows that we have something missing. But that just at least means that we have an error in our code. So let's see if we can figure out what's going on with that. And so what I'm going to do, the first thing, that is the 2. So if antenna is not equal to, then we're going to continue. So we're just going to skip everything except the 2's. And let me actually take out this check key part, just so that I can verify that that's working. No, that's not working. Oh, there, because, yeah, okay. We should only be getting the hashes for that. Okay, yeah, and that looks right. So, yeah, so we're only getting, so let's take a look at our points. Okay, and then let's look at our distances. Just X, just Y, and let's see which of these branches we might be hitting for those points. Okay, that's actually not amazingly helpful. Let's see, so this is going to be 10. One of these points is going to be 10, and this one is going to be 9. So we're looking for a Y9 and a Y10. Which of course I'm not finding. Oh, I'm backwards. It should be 8 and 7. Okay, so that's probably this one here. So that first point, okay, the X is greater than the Y, which makes sense. All right, so we're going to hit here. What are our pairs? 1, 1. And we're going to get that for the second one as well. The X2 and anti-Y2. Okay, so that is a negative. That makes sense, right? Because that goes off. Why is that 16? That seems really big. The distance between these actually... Oh. Wait, that's definitely wrong. That's not the right one at all. Because those... Oh, the distances are actually quite large. So yeah, that makes sense. So the 16 and basically this is... Oh, you know why? Because that's not... We can see that as not actually there. So we should actually round this. And that might be the issue. Let's round these. Dot round. This. So yeah, that's why, because we got this really weird coordinate point there. We could actually put it, it's fine. Let's say I could round it here, but we probably should not do that. And yeah, so that's definitely the issue for why that's not showing up anyway. I don't know if that's the issue for why we have too many. It's kind of a weird issue to have, having too many points. don't fully understand that, but let's see if what that gets us now. Okay, cool, 16.6, and that, yeah, okay, now it shows up. All right, so that was actually not, well, that could lead us to having too many, because if the coordinate point is not exactly the same, the key is not going to be exactly the same. And, okay, that gives us 7 anti-pairs. So what if, just take that out, and we bring this back. I want to turn this off too. Actually, I just want to turn this entire thing off. Because it's not going to be super helpful when it's in its all glory. See, that gives us a couple less. And I think that's the issue. I think the issue there was that those coordinate pairs weren't overlapping at the right points because they were off in a decimal way. So let's just see if 327 works. There we go. All right, so that would be part 1. Before we go on to part 2, let's just take a look at our algorithm here. All right, so first we're getting in our map, or as we get in our map, we're actually not reading it into a two-dimensional array because we don't actually care to walk across the map and make changes to it like we were before. Instead, we just care about the coordinate points. Probably could have done this for part 7 as well, but that's fine. So here we just care about where our antennas are and what type they are, and then also the width and height. So we're not dealing with this massive map. We're just dealing with the points because we're doing geometry on them. Get the inverted map, and that's literally just for drawing. So this is actually not necessary, I think, for anything else. But it's just the map by the coordinate key, or the antenna by coordinate key instead of the coordinates by antenna. Okay, so for every antenna, we look through that, we get our coordinates, we look through all of our coordinates in a double loop, in an n-squared loop, and get each point because we want to find the anti-points for each point, or anti-pattern, whatever they called it. We figure out the slope, we figure out the intercept, we figure out the distance between both sets of points, the x and y, because we're going to use different formulas. So if the x distance is greater, we use that standard y equals mx plus b to get the larger point off of, or we go off of the smaller point, then we go off of the greater point, the distance, so that we have those 2 points and those 2 points up there. And then we figure out their x and y's. Otherwise, we do the same thing, but with the y coordinate using x equals y, I think it's y minus b over m for that. So, yeah. And then we get our count. It's interesting. Took a while. Let's take a look at part 2. Okay. Resonant harmonics. Oh no. And if an antenna occurs at any grid position exactly on with 2 antennas the same frequency regardless of distance. This means that 2 antennas the same frequency will occur at the position of each antenna unless that antenna is the only one of its frequency. Okay, so now they create multiple, so they just keep going until they're off the map. All 3 T-frequency antennas are exactly in line with 2 antennas, so they are all also antinodes. Oh, so these also are antinodes. Well, 2 antennas. What does that mean? Oh, then at least 2 antennas are the same frequency. Oh, so because this is at the junction of 2 antennas, I think, is what that means. All 3 T-frequency antennas are exactly in line with 2 antennas. Okay, so that's going to be the harder part there. This part, extrapolating on there, is going to be pretty easy, I think. This one has 34 antinodes, including antinodes that appear in every antenna. Yeah, so this part is actually not going to be that hard because we already know how to find this data. We basically just, at this point, need to loop on these until we go off the edge of the world. So let's do this. We're going to set this to current. And we go for the minimum, okay. And now we're basically going to go backwards. So while x is greater than 0. Okay, greater than or equal to 0. And we're just going to loop over this. Oh, you know what? I should really be moving this somewhere else. There we go. Let's create a copy of this. There we go. And then we'll set this to be our sample. So this one, we just really need to continue along that line while, I messed that up, that should be a const. We'll just change that there. While cur x is greater or equal to 0, then we're going to just create anti-pairs off of it and just keep doing that forever. Anti-x is going to be current x, okay, and then current x minus equals, actually becomes anti-x1. And let's just see what that does to start off with. Okay, let's take this out. I don't want the check key for now. I should have written that a little bit better. Okay. That is, oh, that's still run against part 1. That's why. Okay. So now we can see that goes off in many more directions. I feel like I kind of want to just do the 0 for now and just see what that gives me. Okay. So yeah, so this now goes off into the distance like that, which is perfect. That's exactly what we want. We're going to do the same thing here. While current x is less than width. Okay, pop that in there. This is current x, and then current x equals anti-x2. So we go that direction now. Okay, now you can see now it goes off that direction as well. So that works pretty well. Now we got to do these, the y, where the y is, okay, so kind of same idea. Current y, while current y is less than or equal, oops, greater than or equal to 0. Yes, like I said, this is going to be the easy part. Oops. The hard part is going to be that second thing that they were saying. y1. I really wish I'd made this something a little bit more, so I didn't have to keep typing this. Is less than height. And the height, less than height, because we are dealing with a 0 indexed coordinate pair system still. Equals, okay, cool. So let's see what that gives us. Yes, that is true. This should be cur y, and this should also be curry. Okay, and now that goes the other direction as well. Those go the other direction, totally fine. Let's grab the ones for this. Okay, so now we got 29. Okay, looks like a fucking mess, but we've got a lot more now. So now they're saying, okay, 34, so we're missing 5. Okay. An antinode occurs any grid position exactly in line with 2 antennas, same frequency regardless. Some of the new antinodes will occur at the position of each antenna, unless the antenna is the only one in its frequency. So these 3, okay, so we have 1, 2, 3, 4, 5, 6, but these 3 are also, these now create many antinodes. Exactly. Oh, you know why that is? That's actually not that hard. That means we just have to have 0.1 and 0.2 on our list. Okay, that's all that means. They used a bunch of fancy language. Yeah, but yeah, if 0.1 and 0.2 are on that list, then that's totally fine. That actually gives us what we want. What they're saying is if there's just one antenna, because obviously if there's more than one antenna, you're going to get those anti-frequencies because you're having a line between 2 of them. So let's just do that then. Key 1 equals 0.1.x, 0.1.y, and then, yeah, sure. And then what am I adding this into? Anti-pairs. Key 1 equals antenna, pairs key 2 equals antenna. Okay. Now if we do that, we now get 34. Cool. So let's actually take this out again, and let's try it on our input. Okay, that gives us 1, 2, 3, 3. Let's put that in. And there we go. All right, so let's take a look at our code. Basically, very similar here, very similar here. Only difference here is we're actually adding our specific antenna themselves into the anti-pairs because they are in that line. And then, instead of just going one step in each direction, we basically just do the entire line until we skipping distance until we go off the map. And yeah, that's basically. Let me see if I can go back to, yeah, so that's basically what they're doing here. They're just doing every line constantly. Anyway, pretty interesting. Hope this is interesting for y'all. I'll see y'all next time.